Alright, so this time we're solving problem 40 from chapter 4. And the question states, two blocks are connected by a light horizontal rope sitting at rest on a horizontal frictionless surface. Ugh. Block A has a mass of 15 kilograms and block B has a mass of m. A constant horizontal force of 60 newtons is applied to block A. In the first 5 seconds after the force is applied, block A moves 18 meters to the right. Part A, while the blocks are moving, what is the tension in the rope that connects the two blocks? And B, what is the mass of block B?
So we'll draw a picture first. So we got block B connected by a rope to block A that has a force moving it
that direction.
So we know that block A, the mass of A, is going to be equal to 15 kilograms. Mass of block B is one of the things that we're looking for. And we know that the force applied is 60 newtons. We know that it travels a distance of 18 meters. They both travel that far in a time of 5 seconds. So we know that if we just look at block A, we know that the net force is going to be equal to the force pulling on it minus the tension.
And we don't have to include friction because it's a frictionless surface.
And that is going to be equal to the mass times the acceleration. So in this, we don't know what the tension or the acceleration is. But with another equation, we can find one of them. So we know that using the equation, the x, the distance, is going to be equal to the initial velocity plus 1/2 the acceleration times time squared. We can then use that to find this, because the initial velocity is 0, because this start from rest. And we know this. So we then know that A is going to be equal to 2x divided by t squared. And that is going to be equal to 2 times 12 divided by 5 squared. And that gives us an acceleration of 1.44 meters per second squared. So we then have A. So we can then write this equation that the tension is going to be equal to the force minus the mass times the acceleration. And so then when we plug everything in, that's 60 minus 15 times 1.44, and that is equal to a tension force of 38.4 newtons. But what the question is asking for is the mass of block B. So now, because we know the tension, we can then reuse this equation, that the force, but in this case, So because we know that the tension is pulling on that, and it's gonna have the
Same acceleration as A.
we know that the tension is gonna be equal to the mass times the acceleration. So we can take the tension and solve for the mass. So the mass of B is going to be equal to T divided by A, and that is equal to 38.4 divided by 1.44 liters per second, and that gives us a mass of 26.67 kilograms, and that's our answer.